Welcome, my friends. In this video, we will use the sum and difference identities to prove additional identities. Let's start with this problem. We are asked to prove the identity sine of pi plus x is equal to negative sine of x. We note that the sum identity for sine is sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. Let's apply that to our problem. We have sine of pi times cosine of x plus cosine of pi times sine of x. At the angle pi on the unit circle, the y-coordinate, or sine, is equal to 0, and the x-coordinate, or cosine, is equal to negative 1. Plugging those values into our problem, we have 0 times the cosine of x plus negative 1 times the sine of x. 0 times the cosine of x is just 0, and negative 1 times sine of x is just negative sine of x. At this stage, we have matched the right-hand side, so we are finished with our proof. Let's try another problem. We are asked to prove the identity tangent of 2 pi minus x is equal to negative tangent of x. We note that the difference identity for tangent is tangent of x minus y is equal to tangent of x minus tangent of y divided by 1 plus tangent of x times tangent of y. For our problem, x is 2 pi and y is taking the place of x. Therefore, we have tangent of 2 pi minus tangent of x divided by 1 plus tangent of 2 pi times tangent of x. We know that tangent of 2 pi is equal to 0 because 2 pi is coterminal with 0, and tangent of 0 is equal to 0. We have 0 minus tangent of x divided by 1 plus 0 times tangent of x. Simplifying, we just have negative tangent of x divided by 1. This is the same thing as negative tangent of x. We justify the last few steps by algebra simplification. We have shown that tangent of 2 pi minus x is equal to negative tangent of x. Let's try this problem. We are asked to prove the identity sine of x plus y divided by cosine of x times cosine of y is equal to tangent of x plus tangent of y. We have sine of two angles added together in the numerator. We know that the sum identity for sine is sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. We can substitute this into the numerator of our expression. At this stage, we can split this into two separate fractions. We have two terms that are added in the numerator over one denominator. We will have sine of x times cosine of y divided by cosine of x times cosine of y plus cosine of x times sine of y divided by cosine of x times cosine of y. Cosine of y will cancel in the first term, and cosine of x will cancel in the second term. We will be left with sine of x divided by cosine of x plus sine of y times cosine of y. We justify these last few steps by splitting up the fraction and canceling, all related to algebra. Finally, we know that sine over cosine is the same thing as tangent, so we have tangent of x plus tangent of y by the quotient identity. At this point, we have matched the right-hand side. We have proved that sine of x plus y divided by cosine of x times cosine of y is equal to tangent of x plus tangent of y. Let's try one final problem. We are asked to prove the identity cosine of y times cosine of x minus y minus sine of y times sine of x minus y is equal to cosine of x. We have the cosine of the difference of two angles and the sine of the difference of two angles. The difference identity for cosine is cosine of x minus y is equal to cosine of x times cosine of y plus sine of x times sine of y. The difference identity for sine is sine of x minus y is equal to sine of x times cosine of y minus cosine of x times sine of y. I've simply substituted those into our problem. So where we see cosine of x minus y, I have substituted the difference identity for cosine, and where we see sine of x minus y, I have substituted the difference identity for sine. Next, we can distribute. We will have cosine of y times cosine of x times cosine of y, which creates cosine of x times cosine of y squared, since we have two cosine of y's, plus cosine of y times sine of x times sine of y, minus sine of y times sine of x times cosine of y, which we have here, plus, since the minus signs cancel, sine of y times cosine of x times sine of y. But since we have two sines of y, we have sine squared of y. The middle two terms are identical, although they are not in the same order. Of course, that doesn't matter for multiplication, because multiplication is commutative. We have cosine y, we have sine x, and we have sine y, with the only difference being the negative sign. After we cancel the two terms, we will be left with cosine of x times cosine squared of y plus cosine of x times sine squared of y. We can factor out a cosine of x, since both terms have a cosine of x. We will be left with cosine of x times cosine squared y plus sine squared y. We justify the last several steps by algebra, distributing, simplifying, and factoring. Finally, you should hopefully recognize the inside of the parentheses here as the Pythagorean identity related to sine and cosine. Sine squared of x plus cosine squared of x is equal to 1. That means that the inside of our expression is equal to 1, so we have just cosine of x times 1. This is, of course, just cosine of x. At this stage, we have finished our proof. We have shown that the left-hand side of the equation is the same thing as the right-hand side. Alright, my friends, that finishes this video proving identities related to the sum and difference identities.